Did you know your stomach needs a special kind of acid to break down the food you eat? But why is having just the right level of acidity so important for digestion? Well, today we are going to uncover the fascinating world of acids, bases, and salts, and see how they play a crucial role in our daily lives. Let's begin by learning what are acids. An acid is a substance that produces hydrogen ions when dissolved in water. When acids or ionic compounds dissolve in water, they break into smaller particles called ions, which is called dissociation. Example: hydrochloric acid dissociates into hydrogen cations and chloride anions. Acids have a sour taste and they turn litmus paper to red. Let's learn about the different types of acids. Strong acids. An acid, which dissociates completely or almost completely in water, are strong acids. So, complete dissociation is when a compound fully breaks into its individual ions in water, with no intact molecules left. Hydrochloric acid fully dissociates in water, so is a strong acid. Weak acids. Acid that dissociates only partially when dissolved in water are weak acids. Examples: oxalic acid and lactic acid. Let's learn about what is a base. A base is a substance that produces hydroxide ions when placed in water. When bases or ionic compounds are dissolved in water, the ions dissociate. Examples are sodium hydroxide and potassium hydroxide. Base are the substances that are bitter in taste and soapy in touch. They turn litmus paper blue. Let's learn about the types of bases now. Strong bases. Strong bases are those which ionize in water completely and produce a large number of hydroxide ions. Example: sodium hydroxide and potassium hydroxide. Weak bases. Weak bases are those bases that partially ionize in water and produce a little amount of hydroxide ions. Example: ammonium hydroxide. Let's now see some important reactions of acids and bases. Reaction with metals. Acids and bases react with metals to form salt and release hydrogen gas. So, acids or bases plus metal gives salt and hydrogen gas. Let's understand examples. Zinc, which is metal, reacts with sulfuric acid to form zinc sulfate, which is a salt, and hydrogen gas is released. Similarly, sodium hydroxide, which is a base, reacts with zinc, which is a metal, to form sodium zincate, which is a salt, and hydrogen gas is released. Acids and bases react with metal carbonates and metal hydrogen carbonates. Acids react with metal carbonates and metal hydrogen carbonates to form salt, carbon dioxide, and water. Bases do not react with metal carbonates and metal hydrogen carbonates. Acids and bases react with each other. The reaction between an acid and a base is called a neutralization reaction. It results in the formation of salt and water. Let's see an example. Hydrochloric acid, which is an acid, reacts with sodium hydroxide, which is a base, gives sodium chloride, which is a salt, and water is released. Reaction of metallic oxides with acids or bases. Metallic oxides with acids produce salt and water. Metallic oxides are basic in nature. Reaction of non-metallic oxides with acids or bases. Non-metallic oxides with bases produce salt and water. Non-metallic oxides are acidic in nature. Let's see some common characteristics of acids and bases. Both acids and bases can conduct electricity when dissolved in water. They can react with each other in a neutralization reaction to form salts and water. Acids and bases can be strong or weak depending on ion production in water. They are used in various chemical applications. Example, acids are used in batteries and bases are used as cleaning agents. Let us now learn about indicators of acids and bases. Indicators are substances which, when added to an acid or base, change color and help decipher the nature of the substance being tested. There are three types of indicators: natural indicators, synthetic indicators, and olfactory indicators. Natural indicators are organically found in nature. Some common examples are litmus and turmeric. Synthetic indicators. Synthetic indicators are indicators which are synthesized and created by chemical processes. Some of the commonly used synthetic indicators are methyl orange and phenolphthalein. Olfactory indicators. Their smell or odor changes when mixed in an acidic or basic solution. Example, onion or clove oil. Let's now see how strong are acid and bases. Amount of hydrogen plus ions present in a solution can be measured by using a universal indicator. It shows different colors at different concentrations of hydrogen ions. A scale for measuring hydrogen ion concentration in a solution is called pH scale. pH is measured from 0 to 14. pH of 0 means the substance is very acidic. pH of 14 means the substance is very alkaline. The higher the hydrogen ion concentration, the lower the pH value. Here are the pH values of various solutions. You can see that lemon is acidic in nature and is having a pH value of 2. Water is neutral and having a pH value of 7. Soap is basic and having a value of 12. Let us now see the importance of pH in everyday life. pH levels greatly influence plants and animals. Specific pH ranges are essential for enzyme, hormone activity, and digestion. Optimal soil pH for plant growth is 6.5 to 7. Optimal digestion in the stomach requires a pH range of 1.5 to 4. Hydrochloric acid, HCl, presence in the stomach affects enzymatic reactions in food breakdown. Tooth decay can occur when the pH around teeth drops to 5.5 or lower. Let us now see what are salts. It is defined as a substance that is odorless, salty in taste and soluble in water. Its pH value is equal to 7. Examples: sodium chloride, which is commonly known as table salt, and Epsom salt, which is used as a bath salt. Salts are formed as a result of neutralization reactions. Let us now learn about the pH of salts. Salts of strong acids and strong bases are neutral with a pH value of 7. For example, strong acid hydrochloric acid, when reacted with a strong base, sodium hydroxide, gives common salt sodium chloride. Sodium chloride is a neutral salt with a pH of 7. Salts of strong acids and weak bases are slightly acidic with a pH value of lesser than 7. For example, strong acid, hydrochloric acid, when reacted with a weak base, ammonium hydroxide, gives an acidic salt, ammonium chloride. Salts of weak acids and strong bases are slightly basic with a pH of greater than 7. For example, sodium hydroxide, a strong base, when reacted with a weak acid, carbonic acid, gives a basic salt sodium carbonate which has a pH of higher than 7. So, students, salt play an important role in our daily lives. We already know common salt is used for many day-to-day purposes such as cooking and even in preserving food items. But apart from this, common salt has many industrial uses. Some products made from common salt are caustic soda, which is used to prepare soaps and detergents; baking soda, which is used in baking as well as an antacid; washing soda, which is used as cleaning agent; Bleaching powder, used to purify drinking water and for bleaching cotton and linen. You can now study chapter notes, watch video lectures and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 10. Thank you.